Hello everyone, this is Yuchen. I am very excited to be able to talk to you a little bit about my work, Beyond Essentials, Nuance and Diverse Text to Video Retrieval. The growth of video content has been fueled by the mass digitization and the booming of smart devices. Nowadays, the sheer size and diversity of video content available in various archives present a significant challenge in terms of navigability and accessibilities for users. An effective retrieval system for video archives are therefore very essential. One of the approaches for accessing and navigating large video collection is the text-to-video retrieval, which enables user to find video content by matching it to arbitrary natural language inputs. It's a very flexible method, and it sort of matches the user's diverse needs for video content, making it kind of an ideal way to enhance the user interaction with video archives. The current text-to-video retrieval models typically rely on training data composed of paired text and video segments, where the text descriptions align with the video content and provide effect-based summaries. For example, in the commonly used MSRVTT dataset, descriptions for videos are typically like soldiers in uniform talking together, or as in this example, a black and white horse runs about. The goal is to align video and text representations in the same Latin space through different learning strategies, and this ensures paired text and video representations or vectors are close enough in the joint space, allowing new inputs to be mapped accordingly into the space and used to find relevant content based on the similarities in the space. Just as text can serve numerous communicative functions, descriptions of video content can also vary widely in terms of focus, style, and intent. The user might describe a video broadly, focusing on the overall theme or emotional tone rather than specific visual elements. Alternatively, they might emphasize like the stylistic aspects, the narrative arcs, or subjective impressions of a video. However, current models might struggle to interpret such nuanced language as queries, as they are predominantly trained on retrieval content based on more straightforward and factual-based visual descriptions, as you can see on the screen. This work then has two primary objectives. First is to introduce a text-to-video retrieval method that can efficiently handle a little bit more wide range of query types. And secondly, to evaluate our proposed method against existing models using a broader and more diverse set of non-standard queries. There are several streams of works already out there on sort of improving the text descriptions for the training of a text-to-video retrieval model. Some of them work on a cleaner and more concise and grammatically correct text, adding conceptual keywords, adding different texts to make it like a little bit more detailed. Others works on integrating multimodal language models to rewrite or generate completely new training pairs for like large-scale pre-training for these type of models. However, the focus of these type of text descriptions are still on the visual and event level features, and it's getting like very focused on the details and like the factual, the temporal orders of things as well, but overlooking the complex audio cues, the stylistic nuanced, more emotional things in the videos. On the on the other hand, there are also two main streams of how people align or match or fuse the multimodal information pairs or different combinations of modalities information used or involved in these type of text-to-video retrieval. Most models build one shared embedding space using combined losses, aligned embeddings directly into one unified space, simplified alignment, very efficient, but it might lose some of the nuanced distinctions. In contrast, um, other works proposed a hybrid space learning kind of a methodology using multiple distinct latent spaces, each specified for different cross-model relationships, which sort of captures the union of the semantics across different modalities instead of the overlapping part. This makes the hybrid space learning method a little bit more suitable for scenarios where diverse or even conflicting semantics informations needs to be embedded in a sort of a manner for different retrieval tasks. However, this type of method are not very well explored for like the text-to-video retrieval applications. Based on all of these insights, this work proposed a model that is both holistic and adaptive, aiming to advance text-to-video retrieval through a more comprehensive multimodal approach. As you can see in the graph where we show like a higher level overview of the architecture of our method. To improve the information extraction from the video content side, this model uses transformer-based backbones for both visual and auditory components. And, and then an audio-visual attention block is introduced to progressively integrate audio cues into the visual representations, resulting in hopefully a richer and more unified video representation. And then on the other side, the model uses or incorporates a on-the-go captioner to generate alternative textual descriptions that emphasize the audio elements, the stylistic nuance, the emotional undertones of the video, and these additional captions support hybrid space learning during the alignment phase, where supplementary spaces are trained. This approach enables the model to embed not only the event base and visual informations normally from the original captions, but also the more subtle, intangible video semantics that we created through the different captions on the go. And more specifically, we applied a two-stage strategy to obtain or generate the additional text descriptions for videos. The first stage is on the left side, which is the aim sort of is to obtain detailed and factual elements of interest that we wanted to support various types of descriptions in the second stage. For the audio component, we used the Whisper to get the speech info and a open sourced audio captioner to get the overall audio environment of the video. For the stylistic aspect, we use elements such as dominant color, contrast, and brightness as key stylistic features. And for the emotional part, we implement Emonet for different emotional tone detection in videos. And after obtaining all of these little elements for the second stage following previous work, a large language model is applied to those details and to create or generate a more coherent and consistent textual-based descriptions of those elements, also considering the original caption as some sort of a grounding text or guidance. As a result, for each given video, we obtained additional descriptions for its audio elements, for its stylistic nuance, and for its emotional undertones. And on the right bottom corner, you could see an example of the original caption and the different types of captions that we generated for this given video. And in terms of the evaluation, we used the standard MSR VTT test set for the evaluation, of course, for consistency and for comparison. But also we use the test set as a baseline to generate a new data set or like a new test set to sort of cater our more diverse scenarios. To do this, we have 5 descriptions generated using each video in the test set with a language model called Video Llama 2. And we instructed it to be more diverse focused and not only on the visuals but more on the audio, style, and emotion perspectives. And then for this task, we recruited 9 people through social media following the previous work. Firstly, we had them vote on whether the caption contains false information or not. Secondly, we asked them to score the caption from 1 to 5 to reflect the diversity of focus on for this description on the audio, style, and emotional aspects of the video. Each video is and its paired descriptions are evaluated by 3 evaluators at the end. The caption that contains no false information and has the highest average score on diversity is capped as the query for the new test set for that specific video. Here's an example of this new queries versus original queries kind of a situation. You see that the new queries are first off more detailed or like more elaborated, and then it sort of focuses a little bit more on the more subtle aspects rather than the blunt and like very straightforward event level things. For the evaluation, we used the standard recall at K as the matrix and reported the results using the original test set for comparison and our new test set for understanding models' behavior in more diverse situations. The benchmark SOTA, or like the state of arts, are grouped into 2 groups. Group A with no extensive video to text or text to video pre-training, and Group B where, because nowadays people are using this foundational models or whatever, so the Group B is more on like models with like very extensive pre-training with over 100 million video text pairs in their pre-training dataset. So here in this table, we present the results of different models evaluated using the original MSRVTT test set. Compared to the methods in Group A, where no extensive video text pre-training is used, which is also what our method is. Our method actually achieves a recall it 1 score of 43.1 compared with the other state-of-art methods in this group. Our methods kind of performs at a comparable or even better level. This suggests that our model, although introduced more noisy audio information on the video side, which some of these models don't, as well as more noisy captioning informations on the text side during the training, somehow leverage these kind of additional information more efficiently. Not more efficiently, but like relatively efficiently, and like result in a space that is more or less comparable with other models. And in contrast, Group B methods obviously benefits from its intensive video text pairs in the pre-training, oftentimes over 100 million pairs of them. Shows a great advantage over Group A methods, but it is noteworthy that this advantage or differences in terms of performance decreases with the matrix getting a little bit more relaxed, such as when you look at the R at 10, where all of these state of the art models kind of perform the same, or like performs on a relatively similar level. This suggests that our approach, or like most of the not pre-trained approach, remains competitive across a broader retrieval matrix or situations where the retrieval are not that strict. And compared to the results with the original queries from the test set, performances dropped across all models on the new test set for evaluation. This decrease is particularly noticeable for models like Clip for Clip and Expo, where they rely only on the visual information from the video side and does not tap into anything audio related. So if we look into Group A, our method was the least affected by this increase of diversity from the new query set or the new test set, and our method emerged as the best performing approach. And although Group B methods, those foundation models for videos, still lead overall speaking, their performance also dropped significantly. One of the reasons why they can still perform in a more diverse situation is probably because they have this intensive pre-training on like large-scale video text data, and it may contain some sort of information for it to be more robustness in this type of situations, and also it's their objective to be adaptable and robust and scalable for all of these zero shot and like in the wild settings. However, notably, our model performed very comparably in still like the more relaxed evaluation scenarios. If we look at R at 10, our method has only like around 2% difference from the InterVideo 2, which is the leading video foundation model at the moment, showing its competitive edge even in a challenging retrieval context and without the extensive and like resource draining kind of a pre-training situation. So here we have some qualitative results to showcase the benefits of our methods. In this figure, we present an example of the new query, the new test set, where there's a greater emphasis on the audio aspects of the video. Specifically, the query focused on the style of the music being performed and the quality of the singer's sound. So the traditional method, as we benchmarked, which prioritized visual elements, retrieve videos that predominantly features a boy and visually depicting a singing competition. However, the top result of that model does not actually include anything singing, nor does it feature a folk or country style, where the query asked. In contrast, our method applies balanced emphasis on both audio and visual elements. This allows our method to retrieve a video where the boy is not the primary focus, but the song is actually more catered to what the query asks for. Another example here is a query from the new test set that emphasizes both the emotional tone and the audio aspects. Here, the benchmark method retrieves a video depicting a classroom scene where a teacher asked questions and a young student answered. This result demonstrates the benchmark method's ability to infer events and entities based solely on the visual content. However, as the query actually requires a scene featuring two people speaking in children's voice, additionally, the query specified a humorous and light-hearted emotional tone, which the benchmark method fails to capture. In contrast, our method successfully identified the humorous undertone and retrieves the ground truth video as the top result. To quickly conclude, we envision this approach as adaptable to diverse use cases beyond the simple video search on facts, allowing retrieval to meet more complex and varied user needs in the future. Thank you so much for listening, and please do not hesitate to contact me if you have any questions.